Okay, in this section we are going to look a little bit more specifically at some vertical asymptotes, horizontal asymptotes, holds, and actually get the picture of the graph and kind of pay attention to what's happening about it. So here's my function. It's x over x minus 2. I will tell you this, your calculators are helpful, but your calculators get pixelated, and so you are going to have to know a little bit about this, and you cannot rely 100% on your calculator, okay? Your calculators won't show you the holes, I'm just going to tell you that, and they won't give you specific values for vertical asymptotes. They won't draw them in, but you can make a pretty good guess about where they're at. What your calculator will do is give you the general shape of the graph, and that is helpful, okay? So here's what you need to know. First of all, in this case, I'm going to look for my holes or my removable discontinuity. And in this case, I don't have a hole. The reason I don't have a hole is because there's not a factor that I can cancel out of the numerator and denominator. Some people think you can cancel these two x's. Remember, when things are separated by addition or subtraction signs like they are here, you can't cancel any part of it unless you can cancel the entire entity out. So don't think that that can happen, okay? So because I have nothing that cancels out, I have no holes in this case, which is nice, okay? Your vertical asymptotes come from what the factors that remain in the denominator that would make the denominator be 0. So this is what's left in the denominator. If I set that equal to 0, then I would get x equals 2. So I have a vertical asymptote at x equals 2. I'm going to go ahead and draw that in right now. You draw asymptotes with dotted lines because there's sort of an imaginary line that it approaches but never touches. Okay? And then the horizontal asymptotes come from looking at the degree of the numerator and the degree of the denominator. So this is an x to the 1, this is an x to the 1. The degree of my numerator is the same as the degree of my denominator, and my coefficient here is a 1 and here is a 1. I make a fraction out of that, 1 over 1, and 1 over 1 just becomes 1. And this is a y equals. Horizontal asymptotes are always y equals. Okay, so I'm going to draw an imaginary line at y equals 1. And then what I want you to do is just stick this into your calculator so that you can kind of see a general shape. Okay? When you stick this into your calculator, you'll go to your y equals. I want you to notice that the denominator has to be in parentheses. If you don't put the denominator in parentheses, you won't get the right answer. And then you can go ahead and hit graph. And you can kind of get the general shape of it. And all I really need you to do is get the general shape. I don't need you to sit and plot specific points. What I will pay attention to when you graph this is that you have your horizontal, vertical asymptotes in the right spots, and you have your hole marked if there is a hole. Okay? This one doesn't have it. So what I want you to do is just kind of sketch in the general shape of that graph when you go ahead and graph it. Okay? So I'm going to sketch that in, and the general shape of this would look like that. Okay? So that's what I need you to do. And you can see here that the end behavior, if I were to do this end behavior, we did this just as a while ago, but it would go something like this. As x approaches infinity, because I'm moving off the right side, so my x is getting bigger and bigger and bigger, my y approaches 1. Okay, my y's approach 1. And those are just some end behaviors just to remind you of some things from the past. All right, here's another one. So I can factor this, and it will become x plus 3 and x minus 3. And obviously the bottom I can't do anything with. Okay, so now this is what happens. I do have factors that cancel. So when I have factors that cancel, that means I have a hole. Okay, so I have a hole, also called removable discontinuity. I have a hole in the factors that cancel, so I would set x plus 3 equal to 0. Obviously, I get x equals negative 3. Okay, then I will go ahead and plug that in to what remains. So what remains in this fraction is x minus 3. That's all that remains. I will plug negative 3 into that. When I plug negative 3 in right here, negative 3 minus 3 becomes negative 6. So my hole is at negative 3, negative 6. Okay? So I'm going to go ahead and plot that hole in the right spot right now. -3, -6 means I have a hole right there. Okay? Then I look at if there's any vertical asymptotes. Vertical asymptotes come from what would remain in what's remaining in the denominator that would make the denominator be 0. Well, after I canceled this factor out right here, I actually don't have anything left in the denominator, so I don't have any vertical asymptotes. Okay, and then I'm going to look at horizontal asymptotes, and to do the horizontal asymptotes, I will use the rules. Okay, so when I look at these rules right here, I'm going to try to make this bigger. And you have these in your notes. So again, I'm looking at the degree of the numerator and the degree of the denominator. And use the original function to do this. So the degree of the numerator is 2. That's the highest degree I see. The degree of the denominator is a 1. So that means the degree of my numerator is bigger than the degree of my denominator. Okay? When that happens, the degree of the numerator is bigger than the degree of the denominator. There won't be a horizontal asymptote. It will be a slant asymptote. So this is a no vertical asymptote. I'm just going to say that there's a slant asymptote right here. And I'll show you what that means when we make the graph. But that's kind of key to know. Okay, then I'm going to go ahead and I'm going to put this function into my calculator, x squared minus 9 over x plus 3. I will put the numerator in parentheses, and I will put the denominator in the parentheses. Okay, and I'll go ahead and hit graph. It looks like I have just a line, and it kind of does. I want you to notice that your hole does not show up on your graph. If you look at your table, you can kind of see that you have an error in your table right here, so your table will help you see where there's a hole, but otherwise you're not going to be able to see this. But as you move off the left and the right, you can see that the line slants towards the same spot in both directions. So you can see that there is a slant asymptote. All right. And I will just, again, I just need the general shape. So this one kind of looks like a line that goes like this. Okay? All right. Next one. If I factor the top, there's nothing I can do. The bottom will factor as x minus 7 and x minus 3. Okay? So the x minus 7 cancels. So what that means is that I have a hole, and I know that the x coordinate of my hole, I would set the x minus 7 equal to 0. And when I set x minus 7 equal to 0, I get 7. And then I need to plug that into what remains. So what remains right now is 1 over x minus 3. When I plug 7 in, I get 1 over 7 minus 3, which is 1/4. So the y-coordinate of my hole is 1/4. Okay? I'm going to plot that right now. So I have a hole at 7 and 1/4, which is, it's hard for me to draw here because my marker's too fat, but it's right about there. Okay? Then, again, my vertical asymptotes comes from what remains in the denominator that would make my denominator be 0. So in this case, this is what remains in the denominator. And if x is 3, you can set that equal to 0. And if x is 3, that gives me 0. So I have a vertical asymptote at x equals 3. I'm going to go ahead and draw that in. Okay, so I have a vertical asymptote at x equals 3. Then you have horizontal asymptotes according to the rules. Okay, so if you look at your rules, horizontal asymptotes, degree of numerator is 1, degree of denominator is 2. Okay, so the biggest degree I see in the numerator is 1, the biggest degree I see in the denominator is 2. And And so if the degree of the numerator is smaller than the degree of the denominator, you automatically have a horizontal asymptote at y equals 0. That's just how it is. Okay, so if the degree of the numerator is smaller, you have a horizontal asymptote at y equals 0. Okay, so that means I have a horizontal asymptote here. Sorry, it kind of gets, my orientation is a little bit off, but it should be at 0. Okay, then we're going to go to our calculators and put this in. Again, put the original function in, and then make sure you put your numerator in parentheses and your denominator in parentheses. So I will go back here, and again, original function is x minus 7, close my parentheses, divided by x squared minus 10x plus 21. Close, and go ahead and hit graph. So it won't, your calculator will not draw in the vertical asymptotes for you, nor will you be able to see the holes, okay? So just know that that's what's happening there. You will not be able to see the holes. What did I do here? Okay, that looks good. So anyway, you are going to just draw me the general shape of the graph. That's all I need. Making sure that you have your hole marked and you have your vertical and horizontal asymptotes in there and that you don't cross those lines, okay? So when I go ahead and graph this, I just want you to give me the general shape. So the general shape is going to approach that line, and it's going to approach this line, and then of course it'll approach here. It'll have a hole, and it'll approach here, okay? So something like that. All right, last one right here. Just so you know, this is the same thing as 4 over x minus 1 times x minus 1, okay? So what'll happen here is there's no factors that cancel, just so you know. And by the way, this becomes 4, if you FOIL that out, it becomes x squared, and you do your outsides and your insides put together, minus 2x plus 1, just so you know that that's what's happening, okay? So I have no factors that cancel, which means I have no holes. If I look at the factors that remain in the denominator, that would make the denominator be 0. If x was 1, that would make the denominator be 0. This is a repeat, so it's another spot. So that means that I have a vertical asymptote at x equals 1. Okay, I'm going to go ahead and put that in. Okay, your horizontal asymptote comes from paying attention to those rules. All right, so in this case, I do not have any x's on the top. It's like I have an x to the 0. So the degree,
Please come to the front office after the bell.
hang on.
Ogren, Jaden Schmalz, Michael Tankersley, Michael Watt, Jaden Cruz,
Sorry.
and Lori Healy.
Okay, the degree of the numerator is smaller than the degree of the denominator. So the degree of the numerator is smaller than the degree of the denominator, which means that I will have a horizontal asymptote at 0. Okay, so I will have a horizontal asymptote at 0. And then you can go ahead and get the shape. Although it looks like it's an x to the 1 on the bottom, when you actually FOIL that out, it becomes an x squared. So sometimes you have to pay attention to that and just be careful when you're looking at what degrees things are, okay? So then you would go ahead and plug this into your calculators. And I forgot the equation, 4 over x minus 1 squared. So if I put that in here, I'll clear this out. 4 divided by parentheses x minus 1 squared. Go ahead and graph it. And you can get the general shape of that. and see that it looks like that. Okay, so go ahead and draw that on your graph, and you are good to go. Okay, and that should be it for this lesson.